Thanks very much. Welcome to the graveyard shift. Sweet. Yep, welcome to the graveyard shift. I'm glad you all made it. There's been some magnificent talks today. I've learned a lot, actually. And so I'm sure all your brains are feeling like mine right now, fried. And I'm between you and beer, and you're between me and beer. So let's be friends for the next 30 minutes and see if we can get through this together. So yes, I am Derek. That's my LinkedIn QR code. If you don't know me, I am based in Perth in Western Australia, but born and bred from Belfast. I am a Belfast Aussie, and it's an absolute pleasure to be here and talk to you about my career and how I've used it to think about GenAI and what to do with it. So it is a talk about careers, quite a personal talk, and it's really great that I'm giving it in Belfast. So when I grew up in Belfast, this was the career. You get to year 5 and you go and work with David and Goliath. And that was pretty much it. And that's really not what I wanted to do. It's quite welding. It's probably a job that's not going to evolve very quickly. And so I got out of that interesting story, which is really good for a yarn over beer, if you want to hear how I got out of working with David and Goliath. I actually ended up at the University of Ulster as a civil engineer. And is anybody from Moira, Craigavon, or Portadown here? Yes. I know your sewers intimately. Intimately. They are beautiful things. No. So I spent a year surveying the sewer system of Moira, Portadown, Craigavon, doing that, so getting into sewers and measuring them. And as you can expect, that wasn't great. It was probably, again, not the career I was looking for. I was looking for something a bit more dynamic, something that changed often, something that excited me. And civil engineering, yeah, building bridges is exciting, but it never changes, you know. The bridges were built 100 years ago the same way they are now to some extent. And so I ended up in tech, went back to Queen's and done a degree in tech. And with tech, we get wow moments. And this is the reason that I joined tech. It's exciting. It is fun. Things change all the time. And that's a wow moment. That's really exciting. But to quantify what a wow moment actually is, it's a significant change in the landscape, resulting in interest and some unflinching belief that this may change the world. And we're seeing this a lot. Some zealots, I'll call them, for GenAI. Others, meh, not so much GenAI. And this is what I'd say is a wow moment. And I based it on the Gartner hype cycle. I think most of you should be familiar with. The wow moment is the top before we dive into the trough of disillusionment. I've been lucky enough to work in a number of wow moments over a career that's closer to 30 years than 25 in tech. And some of them are there. So mobile, I've done the PC revolution, I've seen IoT and cloud and blockchain, and now I'm seeing GenAI. And when I talk to people about phases and attacking a wow moment and what to do when one comes along in your career, I usually get these questions, all about, will it get me a better job? Do I need to actually invest some time in learning? So coming here, events like this and hearing excellent talks from very knowledgeable speakers. Will it be popular? Will it make me money? And should I start building now? These are typically the questions that I hear globally about GenAI. And power off. See, the GenAI is controlling the AV. It's making me stop. And so to solve these problems, obviously you need a compass, you need a direction, you need to think about how you're going to tackle these things, and there are a number of ways you can do it. You could do it like this. Has anybody ever played World of Warcraft? Yay, we've got a few WoW players here. Is anybody familiar with the Leroy Jenkins meme? Yay, okay, I'm talking to a few here. For those who haven't, are not familiar with Leroy Jenkins, he's a WoW player who was playing WoW one day with his friends who were then planning the raid. So the friends were really having a detailed discussion about what potions to use, what armor you can put on, so they can have the best outcome when they went in and attacked the boss. Leroy wasn't there. Leroy was cooking chicken in the microwave and didn't hear any of this planning. And so came back, sat down at his desk, put his microphone back on, shouted, "Leroy Jenkins," and just ran in and attacked the boss. And the crew followed him because they're a team, and they all died. Now, you can absolutely attack a WoW moment like that. And in fact, early in my career, I did. I was like, yes, what's this? Let's attack it. These days, I take a more measured approach. I love Leroy, but I'm not that Leroy anymore. And this is how I've built this measured approach over time. So is anybody here born after the year 2000? Okay, everybody. This is what phones used to look like. This is what they used to look like. They weren't fancy like they are now. Phone. It was. Excellent. It was. This was the phone from the Matrix. I chose that intentionally. Thank you, sir. So back in the day, before 2000, if you wanted to send any sort of message between two phones, so I'm thinking about an image in particular, you could only send it to the same type of phone because they had the same operating system version on each. And so what we did in 2000 was we decided, well, what if we could change that up and start sending other message types, images, sounds, and stuff like that. And we were able to do that because of the invention of XML, WML, and MIME types, which are now de rigueur. And what we did, we posted the messages on the central email server, a central server application that we built, and then they could be consumed by any phone. So we thought, and as I take this around demoing it at virtual conferences over in the mainland, and the questions we get was, why would we want to spend these crappy images, because these phones had crappy images, they were terrible. Why would we send these to each other? What's the use case? What's the use case? Anybody heard that recently? What's the use case? Turns out, the use case was sending cat memes, but that happened a lot later. And so what we originally built it for was communication. What it ended up with was sending cat pictures, and that's how mobile communications really took off when people started to learn how to send cat pictures. But what I learned from that was it's all about the right mindset. When we built that application, we weren't thinking about, we had a very clear in our minds what the application was going to be. We thought that these different message types would add value to a business. Turns out it wasn't right, but the mindset was to build it anyway. And also what I learned was today, so back then, that wow moment is now a me. You know, we do that all the time. Images are everywhere. Mobile communications, it's a me. It's not a wow moment anymore. So today's wow moment is tomorrow's me. Anybody here a cyclist? What? Oh, we've got a few. Yes, I am a cycling tragic, and I should cycle more. But anyway, if you watch the Tour de France, these days, if you watch the Tour de France, you'll see all these metrics overlaid on the television. It'll tell you how fast the cyclist is going, the power they're generating, and things like that to enhance the viewing capability. Go back down under in 2015, there was a little company that I worked for who were filled with cycling tragics like myself, and we raced every couple of weekends. And we sat down over a coffee, or it was probably a beer, and we thought, what if we could track ourselves and ingest information from ourselves and display it on dashboards? And we went, oh, that's a fun thing to do. This IoT thing is a wow moment at the minute. Let's see what it's about. So we built inside a device an application that ingested everything that it could from the cyclists, so the power, heart rate, speed, all of that, ingested that and threw it up to the cloud where we could then visualize it on a dashboard. And we did this at an event, so a small cycling event in Western Australia, and it took off. So somebody seen this from the media and said, would you like to come to the Tour Down Under? So the Tour Down Under is the professional cycling race in Australia, where all the professionals come. Would you like to do this at the Tour Down Under? And we went, yeah. And so we changed our application to push the information to Channel 9, which was the broadcaster at the time. And I took a little picture. So this was me behind the scenes at the Tour Down Under at the back of the team car. And these are all the devices that we run in the application that I give to the riders every morning. For a cycling nerd like me, it was heaven. And then when we went live on television and we were broadcasting the numbers of the cyclists, the television channel got this feedback. You're making these numbers up, was what people said. And we went, what? No, we're not. That's wrong. They're real. So what happened? Well, next year, Velon, who run the Tour de France, got a really big company to build the same solution. And from every year since, that's where you've seen the visualizations of how you get real-time cycling data into the broadcast. But what did we learn from that one? Gain an understanding. So IoT was interesting, and we ingested it into the cloud as well. So we gained an understanding of those technologies by building this solution, which we loved. And we made it fun and interesting. It was on a topic that we really were quite passionate about, and it was a lot of fun to do. So that is the understandings and lessons that we got from that wow moment. And then we come to GenAI, so the wow moment of the here and now. First lesson that I can reiterate is it's happened before me. GenAI, and we've heard it a few times, is not new. This technology is not new. It's been around for quite some time. Here's a quote. So again, we hear this a lot. How can you trust a GenAI assistant? How can you make sure it's not hallucinating? You need to verify every answer and every artifact. I've heard that before. How can you trust IoT data? How can you make sure it's not just randomly generated? You need to look at each piece of individual hardware. You're making these numbers up. Exactly what we heard when we built the cycling application. Next lesson that I reapply when I think about GenAI is it's all about the right mindset. This is a very noisy clicker, by the way, isn't it? It's a problem of mindset. So this is something I hear, again, very regularly. It's not entirely correct. Well, shift that mindset, because yes, it's not entirely correct, but did it actually save you time? If it saved you time, win. And that's the better mindset to apply to these things. Next lesson is gain an understanding. So I've started as a software engineer, very old and decrepit software engineer. About 18 months ago, I didn't know anything about GenAI. I knew a bit about machine learning. And so I went on a journey to learn it. And so this is my learnings. So if you want to go on a similar learning path as a builder, as a software engineer, learn prompt engineering. Then you learn what a foundation model is, how to select the right one. Then go into RAG. And then talk about agents, tools, and function calling, and then finally get into the complicated stuff, is fine-tuning and pre-trained, if you want to. I stopped about here. And also, the mental model that I started to use is something that a colleague of mine actually created, and it actually makes absolute sense. We have three fundamental users of GenAI: the builder, the business user, and the application. The builder is a developer building applications in their IDE. They're using GenAI at dev time, so they're using coding assistants to generate the code for them using plain text. The business user is then using GenAI consumption time, so looking into a business application where traditionally they would use SQL queries to get the information that they wanted. Now they're using natural language. Then finally, the application, which is the GenAI runtime. So that link there, that QR code, is an example of how a software engineer had a problem of comparing addresses, and all addresses are different. So he needed to write, or they needed to write, I think, a application that, given two addresses, would check for equivalence. That's quite a complex task to do in code, and so he used GenAI to do it for him, and that article is how he did it. And then once you've gained that understanding, you build something. So what I built, and what I also didn't do this alone, and I'll absolutely call this out, is when you're building something, do it in a team. You can do it on your own and be Leroy Jenkins and just go for it. But doing it as a team is much more insightful. You'll learn a lot more of your peers if you can. And this is, I built this in a team. So agents, if you're not familiar with the agentic workflow, it's users input chat. The chat then gets hit by the agent, and the agent is an orchestrator. So it is a contract that it has to fulfill, and it uses tools, other data, other services to fulfill that contract, and an LLM, which for the orchestration, to then return a response back to the user. But that's really boring. So what if we built something and made it fun? What if the users interacted with this agent using agentic workflow using Minecraft? And what if the tools that Minecraft used were the tools that you can do in Minecraft? And what if the bot was a playing character in Minecraft? And we all know the LLMs are magic. You weren't in if you were in the last talk, you know that's an in-joke. And then orchestration would be done, and fulfilling the tasks that you asked the agent to do. So we built it. So we built a Minecraft server. So Minecraft server is open source. And so also open source is a Minecraft bot framework called Mindflayer. And so we initially went and built a Minecraft server, and then sidecard into that would be the Mindflayer bot framework. And then running would be a little client application, which would then send API calls up to agents for Amazon Bedrock, which would be our agent, which would work out what we wanted the bot to do and send the appropriate calls back through the client through Mindflayer to update the actual playing bot. And today I'm going to attempt to demo that. Nobody else has done a live demo today. This is taking the demo gods to a whole new level. So we're going to run the Minecraft server on my laptop, which is over there. We're going to control it from Bluetooth, which is here, and we're going to have a bit of fun, and my laptop is locked. Security, I will be back. Yeah. Password 123. Yes. Yep, got it. Okay, so that's fun bit number one. So this is Minecraft. And the Wi-Fi is going to play. So this is Rocky. So this is the bot. And you interact with Rocky by going, T. Hi, Rocky. And this will send a request up to the internet, and the Wi-Fi will behave, and Rocky will respond. First step done. Come on, can I get a hell yeah? Okay, so Rocky can do things. So let's get rid of the mouse because that's confusing. Okay, let's go and go. Can you jump? Rocky jumps. Can you come? Can you come here? Nearly spelled it right. Will Rocky interpret that? On my way. So what happens is we're using a agentic workflow, and we're using a concept called return control. So we're putting these texts to Rocky, sent to Amazon Bedrock. It has running a return control agent. And so it's trying to work out what tool to use. So jump tool, it's also got a location tool, find location, and it sends that information back. If it needs more information, Bedrock will go back to the client and go, what's the location of the player and what's the location of the bot? And then it will use a pathfinder to get there. It also does other things. Rocky, can you dig a small hole? Oh, shit. Must get out of Rocky's way. So Rocky is now in the hole, and then you go, please come here. If you're polite, I'm fine with Rocky. He's or they are more polite. Come on, yes. And so Rocky, the emergent behavior that actually evolved is Rocky actually digs themselves out of the hole. That's not coded anywhere. Also, Rocky. Let's give some space. Rocky can build, and this is where it gets interesting. If it's not interesting already, it gets really interesting. Please come here. Come here. Come on, Rocky. So what we're doing, we're using Claude Haiku to do the faster commands. So we're using jump, dig, there's other commands. How much time have we got? I've got 5 minutes. Still got 5 minutes? Right, you can do other commands. I'll do the build command at the end because it's different. So these faster commands like find, objects, dig, and stuff like that use Haiku because we want a faster response time. So can you find a pig? So the first time I demoed Rocky was at the Singapore Summit. And in my infinite wisdom, I went, oh, gee whiz, there's a pig. That's too close. Please go there. Oh, thank you. Please go there. So Rocky will find objects and go to them. Oh. Okay, so that pig was really too close. Let's try again. Find pig. Yes, find another pig. Go to it. So when we first did this at a conference, we wanted to observe what people were doing. And so what most people were doing was hit a pig. So we built an action to hit a pig. And yep. And so he hit the pig, and yeah, people would spend hours, I'd observe them, and they'd just be hitting stuff. And the other one was they'd dig holes and they'd fill them over, Rocky. Or people are evil. So we only did hit a pig. So so that's the simple commands. The more complex commands is a build command. So building a 2D representation on a 3D space is complex. And so we're using Sonnet 3.5 for this task. Okay, see, can you build a... Okay, what do you want Rocky to build? Shout out, please.
Panzer tank.
Panzer tank? Only in Belfast. Let's try a tank. I haven't done a tank. A tank. Funny. Okay, so what happens is Rocky will start thinking. So we're trying to work out what action to do, and Rocky is not responding at the minute. Let's see. Oh no. Rocky, hello. Just come here. Come, Rocky. No. Okay. We can do this. We can do this. Oh, yes. Oh, happy days. What did you do? Yes. Please. Build. Tank. So I'm going to go command. Let me see. Okay, so this is Rocky. So Rocky this is the application that's running. And this is the build command. So for build, we're actually we're sending a different prompt. So we're going, you're Claude, an expert Microsoft Minecraft builder. And we're sending the structure. So this is how you build in Minecraft. So we send an example of that structure up to the agent. And so we also give it strict instructions, like only particular blocks. Because we find that if you do not give it, constrain it, chaos, even more chaos than this. And then the input tank. So this usually takes a minute or so. So what Claude's doing is given those constraints in the prompt, it's trying to work out what a tank does, and then return what a tank looks like in 2D, extrapolates that into 3D, and then extrapolates that into Minecraft blocks. And then goes, okay, and you've told me how to build, so it responds with the response. And now Rocky is building a tank. Oh, yes. So Rocky is now building a magnificent tank. I don't know what's going to happen here. It's grey at least. That's a good start. Yeah. I reckon this is going to be. So, what's going on? Okay, all right. I think it's a water tank. Yeah. Rocky is a peaceful bot. And yeah, so Rocky's going to keep building. So that is how basically I learned agentic workflows. And what is? Okay, yeah. Looks like a tank. Yes. Amazing. Yes. So that's how I learned agentic workflows. As you can see, it's flawless. So the good news is you can have a crack at Rocky. And there is the QR code to do that. So if you scan the QR code, you will get a very short survey where you go, Derek is a rubbish speaker, but Rocky's cool. And when you fill that out, you will get a code, a $25 AWS code, and the link to the Rocky open source GitHub repo. Please have a play with it, submit a PR, have fun with it, and maybe learn agentic workflows on the way. So thanks again for listening. It's been my pleasure. It's my first time, 12 years since I've been back at Belfast. Lost a bit of my accent, but I brought the weather. So you're welcome.